Hello, and this is our third and very short string video. This is the third one in order to show you a practical example of how we could really utilize the substrings method associated with a string. As you notice, I have an email here that has been declared as a string. It's a variable. And I have another variable called .edu that has been also declared as a string. Email was assigned jack@university.edu as a literal string. And now I'm going to be looking where is really those four letters, the in that all emails end up with. I'm going to extract those from the email and assign them to .edu. So I'm going to use the substrings that is associated with the strings email. And we're looking at interesting things here. We're looking at the email string, though, regardless of how long is that email, -4, that's mean the beginning of the position that the substring function is going to start to extract from the email string. And it should go as far as 4. So it's going to arrive here if initially email strength -4 is going to really get to back to here. And if from that position is going to go and extract as many as 4 characters. So that's what going to, in this case, is going to extract edu. And as a result, in this case, edu will be assigned based on this example. Of course, any other example that might not have the edu is going to be assigned to .edu. So if .edu in this case is equal to .edu, the string that we extracted, then it's going to say it is an educational site. Otherwise, it's going to say it could be a commercial site or any other site. So this is, again, a very quick video in order to show you how we could use the substrings to extract a domain from an email or even actually a website in order to check if the website is really of certain type of domains. And this could be really very helpful and to use in order to count how many web emails end up with a certain type of domains. Also, you might be able to check if all of them really have the dot as the ended up with a dot something like a .com or .mil or .gov and so forth. There's other functions, many other functions pertaining to the string class in Visual Basic. I would like you to further look at those, but this is again a quick video to give you a practical example of how we use a powerful method associated with the class strings directly built in Visual Basic to compare it to an old legacy type of function like med that we use in video number 2. Thank you for watching, and hopefully we'll continue with more videos. Hello, and this is the third videos. We're going to combine actually these videos with a little bit of a strings and a little bit of a very important subject that's called structured, that's going to result into building a record similar to a database. Very short programs, both of them. That's why I'm combining them in both in one video. If you notice here, I'm going to show you an example of using a practical example of using substrings. I dimensioned an email as a string, and I mentioned .edu as a string. So this is the email jack@university.edu. So if you look at the email, the substrings, I'm going to look at the whole length, which is really the attribute of the strings email. It's going to give me how long this whole strings. In -4, it's going to go up to -4. It's going to be -4 of those. It's going to, that's really the beginning of the position, -4. And it's going to go as far as 4 from that position. So it's going to start right here to count right here on the dot and edu. So this is what's going to extract from this substrings. Is going to go all the way to the length -4, and from that position, which is right here in the dot, going to go as far. So which is really a smart way of looking at how to extract this extension along with the dot. or in this case, it's not the extension, it's the domain of the email. So if the .edu is equal to edu, then we could go ahead and send a message box saying this is an educational site. Otherwise, it could be a commercial site. So this is again to show you that substrings can be used really nicely in a practical example. If you're dealing with a website or checking if the person entered the right type of emails, maybe sometimes you want to look at this as the @ that is part of the email to check for the validity of the email itself. And also if there is a domain, the last four must have a and that position must be having a dot. Anyway, this is a very quick example in order to demonstrate for you, and we're going to go ahead and take a look at now a new subject, completely new. It's going to be in reference to a record. A record in a database is really a full entry that has multiple fields pertaining to one entity in the real world. I'm not going to turn this discussion into a database discussion, but you need to know that before we enter the record, we have to design the structure of that record. For example, if I have a student, the student has a first name, last name, and let's say a number of credits. Those are three attributes pertaining to the entity students. If I got Michael as the name of the students, let's say Michael Roberts, and he finished a number of credits, those actual data is going to form the record. So the record is the actual data, and the structure is the way we design how to handle the record within a file or a database. So this is not really a strange concept for us, because as you notice here, the structure is going to be the keyword here, and I'm doing everything public as a public, and the name of the structure is going to be computer system, which is another way of saying I'm going to define in my environments a new data type, and I'm going to call it computer system. I could call this a user-defined data type, because it's me, the one who's really trying to create that type of a new data type for the environment that I'm working with. And mostly it's made from a small pieces of other type of data like strings, and sometimes, as we see here, date. It's a very powerful data type. It could be integer, it could be float, it could be the decimal, anything that we have learned or we are learning through that. So this is very interesting to know that in this structure that I'm trying to design, it has three pieces pertaining to a computer system: the CPU, I'm doing it as a strings, the memory, I'm doing it as a long integer, it could be really an integer, and also the purchase date, which is a date. So this is going to be manipulated as a date. So this is the design or the blueprint of the record that is going to be established later. So when we get to this, I'm trying to declare now, actually I declared two record, James system, Michael systems as computer system. So this is going to be similar to another data type that we have used or we learn about. Computer system is going to be the data type. James system and Michael system are both records. So now I could go ahead and use an actual data to be assigned to those three members: the CPU, the memory, and the purchase date are the members of each structure that is going to be inherited directly by every record I create of type computer system. So the first value, since I declare CPU as a strings, I'm assigning the i3 type of CPUs to James systems, and I'm giving the memory of James system is 4 gigabyte, and I'm dimensioning here another variable called usable as a boolean. I just want to check if, in my own opinion, if a computer is 4 years old or old or older. That's again up to how I visualize computer. It's going to be an old system. So I wanted to say here, if James system dot purchase date, and look how the date are surrounded with the pound or number signs, then it's going, the usable is going to be true. Actually, in this case, the usable is going to be true if the if it's less, it should be actually, this should be a bigger instead of less. Then I would say here, yes, it should be bigger, because if it's less, it's going to be unusable. So if usable is true, then we could say James has a usable system. Otherwise, James does not have a good system, because it's older than the 1st of January 2009. This is obviously the application of or utilization of the structure in an actual record. And I'm going to actually create, not create, I already created the record for Michael Systems. I'm going to assign the member certain values. So I'm assigning Michael Systems the value i7 for the CPU, 16 gigabyte of RAM, very respectable amount of RAM. And obviously he bought it very recently. And notice that the date is very powerful built in it. If I put, for example, a date of November 31st, there is no such a thing. It tells me date constant is not valid, because it looked really whether I entered a valid date or not, because we don't have a November 31st. The largest, I mean the last day of the month is 30. So that's a good thing to know. And now I'm going to see how we could use the really records to compare them to each other. If I say here, if Michael system.memory greater than James system.memory, meaning if the amount of RAM in Michael systems is greater than the amount of RAM of James systems, then we'll say Michael's computer has more RAM than James. Of course, if it's not, James' computer going to have more RAM than Michael's. So obviously in this example, Michael has 16 gigabyte and James has 4. So we have clearly that we're going to see clearly in the displayed message in the list box that Michael has the more RAM than James' computers. Again, I'm communicating my result to a list box just to keep everything. I could have done that also with the label box, control, but list box allow me to enter multiple values. So I'm going to go ahead and run this to show you that James does not have a good systems. Because if we're going to look at the James, let me go ahead and see what's the date. James purchase is greater than. Let me go ahead and see here how we ended up really getting. James systems purchase is greater than this date here, and we should be able to assign some values. It immediately default to no. Let me go ahead and say this here. James, one second here, I need to assign something to the James system. That date is going to be, let's go ahead and put that here. Let's say he bought it, say 10/1, 2009. Let's see if that's going to change the case here. Okay, one second here. It's misspelled, obviously. Okay. That date, this is going to be purchase date. Let's see if that's going to work now. We're going to run it. And James has a usable system because I put the date greater than the 1st. If I change this to 2008, you're going to see that. I'm sorry I missed that earlier. I was in a hurry to run it through this. James does not have a good system, so it's clearly now it's workable, because this should have been assigned to this value. What I was testing here against really no value, so that's why I defaulted to false immediately. So that's a good way. I'm going to leave the mistake. I'm not going to erase it or record the videos. So it's an oversight. Now we have it there. We clearly about that we have to compare a date to a date in order to get some valid result. So this should be able to give you an idea. Notice also that we could compare the two dates to each other if we want to. But again, I was saying this should give you a good idea about how a record should be, first of all, designed. Like to use the word designed. Then, of course, implemented. In this case, we're implementing the actual use of a record. Here is a structure, and here is a record. Thank you for watching, and I hope you will continue watching future videos with me.